Hello there. In this video, we're going to learn how to write a proper algorithm. Okay? Before we begin, I must start off with the components of a program. Now, the three basic components of a program are input, processing, and output. Right? So, whenever you're writing an algorithm, these three things has to be addressed. Right? So, to demonstrate this, I've drawn a small figure. So, we feed our inputs. Let's say in this particular example, I'm demonstrating addition of two numbers, right? So to our program, we feed in two numbers, A and B. Then under processing, we add them. And then finally, the output is our sum. And this entire thing constitutes our program. Therefore, whenever you're writing an algorithm, you have to address these three components of a program. Moving on. Now, there are some misconceptions and myths that I want to bust out open about algorithms. The first being that it is a waste of time. Wrong. It is not a waste of time. Do you know why? Because algorithm helps us plan our way into writing the programs. Take, for example, you're throwing a birthday party for yourself, right? So what do you do first? Do you randomly call up your friends and invite them to a party, call up restaurants and order stuff? You don't, right? You plan out your birthday. You select which friends are going to come to your birthday party. You select from which restaurant you're going to order food, or if it's going to be prepared at home. You select your cake, whether it's going to be chocolate cake or strawberry cake or vanilla cake. That's your choice, right? So you plan first and then you execute. So algorithm helps us plan our program. So the first thing that you should do whenever you get a problem, a program problem, is you should take a pen and a pencil, write down the things, take an example. For example, testing whether a number is prime. To take a number and see how you can determine whether that number is prime using pen and paper. And then you translate those deductions into a program. You write them down into an ordered format. I've often seen students who first start writing programs and then they become, what should I say, then they are confused about what they should write. This is the reason why you should plan first and execute later. Now, moving on to the second misconception that students usually have about algorithms. An algorithm should be written after you have completing writing the program. No, absolutely not. This is a very big misconception. That's absolutely wrong. You should plan first and execute later. And if you do the opposite, you're bound to be doomed. And your program's gonna have a ton of problems because you don't know the logic clearly. Unless and until you can solve the problem on a piece of paper, you don't know the logic or the approach to your problem. Program comes much later. Algorithm or the planning comes first. So please write your algorithms, decide about what you want to do, and then move on to programs. Moving on to the last misconception, last but not the least, an algorithm is redundant, the program is enough. No, yet again, this misconception is this myth. It's myth, right? This myth is busted. Why so? Let's say you're working on a very big project when you have joined the company, right? So there are multiple teams working on a project. So in case of web projects, there are tons of languages, right? Tons of programming languages through which you write out the web apps. All right. So let's say you are familiar with Java and you wrote a program in Java. Now there's someone else on the other team who is familiar with Ruby. Now Java and Ruby are not alike. So a person who has a background, who knows the Ruby language, they cannot decipher what you have written in Java because the syntaxes are different. Therefore, an algorithm is required because an algorithm is independent of programming languages. An algorithm can convey an idea much faster than a program would do because an algorithm is usually written as a pseudocode or in plain simple language, which is which a layman would also understand. This is the reason why algorithm is not redundant. And please do not delegate algorithm to a secondary position. It is a very important thing in programming. If your algorithm is correct, your program will run too. And if it doesn't, there may be some syntactical errors that you will need to correct. But if your algorithm is not right, if your planning is not right, then when your program crashes, you have to deal with two things: syntactical errors and logical errors. And I'm telling you, logical errors are very tough to figure out in a program, to find and solve. But syntactical errors, compilers will help you. They will tell you the exact line and the exact point where the error has occurred, and you can easily fix it. But for logical errors, compilers have their hands tied. They cannot help you in that regard. Therefore, make sure your planning is perfect, or if not perfect, plan ahead, execute later, right? Okay. Okay, all right, no problem. Okay, so what are the building blocks of an algorithm? The first thing that I must say right out front is that the algorithms are not rigid. For example, an algorithm to test whether a number is even or odd, uh, if written by you and your friend, would not contain the exact same words, but the logic or the idea that both the algorithms convey would be the same, right? So therefore, algorithms are not rigid; they are flexible. You can write your heart out in an algorithm, but please don't write lyrics of songs in algorithms. That is not the purpose of an algorithm, right? So algorithms are not rigid, they are flexible, and there is no hard and fast rule to write an algorithm. Though there are some conventions that we follow, but still an algorithm does not need to be same with someone else's. You may use it, you may have a different choice of words, that's completely fine. Right? So generally, the algorithm can be written in one of the two ways. The first being step by step in plain English language, and second being in pseudocode. Now, when I was in ISC, I was taught to write algorithms in step-by-step fashion, right? Description of each step in plain English. Therefore, that's what I'm going to cover next. Now, I learned pseudocode a way later when I came to college, so I'm going to prefer this for ISC. All right. All right. Now, there are some things that you should note when writing an algorithm. The first thing being, every step of an algorithm has to have a number. That is the reason why every step of the algorithm is preceded with step I colon, where I stands for the step number. So, for example, the first step would begin with step 0 or step 1, then step 2, step 3, and so on. Get it? Moving on to the next one. The first step, step 1 or step 0, as the case may be, should be start. The first step should be start, and the last step should be stop. Okay? Please, you need to follow this. If you don't, your marks will get deducted, and I don't want it. And you don't want it. So please adhere to this. Now, moving on to the third point, and it's a very important point too. An algorithm, as I discussed before, is independent of any programming languages. This is why you should never write programming syntaxes in algorithms such as system.out.println, math.pow, i++, etc. Algorithms are program independent. Your algorithm should be such that if you give it to a Java developer, they can read your algorithm and write a program. If you give your algorithm to a Ruby developer or a MATLAB developer or a Python developer, even they should be able to translate your algorithm into a concrete program. So, never write programming syntaxes in algorithms. Now, moving on to an example of an algorithm. So, how should we write conditions in our algorithm? So, in this example, I've shown how do we write an algorithm to check whether or determine whether a number is even or odd. Now, as the second rule states that the first step of an algorithm should be start. Therefore, I've written step 1 is start. Now, in step 2, and moreover, I need to say something first about before beginning on with the algorithm. I said in the very first slide that an algorithm must address three components of a program: input, output, input, processing, and output. So in step 2, we are actually addressing input, right? So we are inputting a number and storing it in num. All right. Now, step 3 and step 4 are for the processing or the calculations that need to be done in our program. So even that has been addressed in this algorithm. So in step 3, we calculate the remainder that we get after dividing num by 2. Now you may ask, well, modulus is an operator of Java, right? So you just said now that we shouldn't use any programming syntaxes. But the thing is, modulus, the symbol for modulus is percentage even in maths. It's a well-known symbol. It is not restricted to Java. All right. So this is the reason why we can write mathematical expressions in our algorithm. Now, in step 4, we check whether the remainder is 0 or not. If the remainder is 0, we display even, otherwise we display odd. Therefore, this takes care of the third aspect of a program, that is output. And as always, the last step should be stop. Get it? Let's see how loops are written in an algorithm. Now, in an algorithm, we don't have the privilege of for loops and while loops. Therefore, what we do is we use the help of go to step number to help us repeat a few steps over and over again, right? So the algorithm that you see on the screen is for determining, or not for determining, I'm sorry, for generating numbers between LB and UB, lower bound and upper bound, that has been given input by the user. The first step, as always, is start. The second step is to input number in LB, comma, UB. You can take multiple inputs separated by comma. You can write this in this way. There's no specific way. As I mentioned, that algorithms are flexible. You can break this up into 2 lines, input a lower bound in LB, input. In fact, I should do that. Input lower bound comma upper bound in LB, comma UB, and because I don't have a space, assume that I've written respectively, right? You could break this up into 2 steps. That's completely up to you because algorithms are flexible. So in step 2, I'm addressing the first aspect of a program, that's the input. Now, in the third step, what we do is we take I and we store. I is a variable. Variables are not restricted to programming languages. Variables are used in maths widely. We take a variable I and we assign it the lower bound. Then in step 4, we display the value of I. So let's say the user has given LB to be 1 and UB to be 5. So I would have the value of 1 and we are displaying the value of 1 in the next step, right? The steps are executed sequentially, mind you. Now, in the 5th step, we increment the value of I by 1. But you should write I equal to I plus 1 and not I plus plus, as this is a syntax for Java. Such kind of syntax or operator is not available in Python, not even in MATLAB. That is the reason why I ask you to refrain from using syntaxes which are restricted to a programming language. All right. Now, in the 6th step, we check whether the value of I is less than or equal to the upper bound, meaning whether the value of I has crossed the limit or not. If it hasn't, we go to step 4, that is this step, and all of these repeats until I is no longer less than or equal to UB. When we stop and go to step 7. So this is where go to helps us to repeat a few steps multiple times. For example, the steps 4 through 6 will be repeated several times until this condition becomes false, right? So this is how you write loops in an algorithm. So this was a brief introduction to algorithm and a few examples that we have covered in this video. In the next video, we are going to take the example of an ISC program and write an algorithm for it. Well, great, I downloaded the Punisher. All right, so in the next video, I'm going to we're going to take an example of an ISC program and show you how I would write an algorithm for it. All right, so see you in the next one. Bye for now.